Hello everyone. Welcome back to the maths class of Mount Litra Z School, Surat. In today's session, I am going to explain you equivalent decimals, like and unlike decimals, position of decimals and conversion of unlike decimal into like decimal. That is your chapter 5, decimal numbers. Clear? Now, what is an equivalent decimal? Decimals that name the same number are called equivalent decimal. Can you see the example? In this picture, both the fractions are same. Why? Here 0.8 and here 0.80. On 10th number we have 8 here, and here also we have 8. So this way they are same. Examples 0.8 and 0.80. So that way they are same in number. Next, position of decimals. In live session already we have discussed. What we discussed? See, in this picture we have placed decimal point, and before decimal point how we place the number according to Indian system, the same manner we have to place. But after decimal point, how to place? Can you see this? After decimal, the first digit after decimal, that will count as a 10th place, the next 100th place, on the next 1000th place. So how you are going to read this number? 269.374. This you have to keep it in mind, that after decimal each and every digit you have to read separately. How I read? The same you supposed to. I repeat it, how you have to read the number in decimal way. 269.374. Clear? Now, decimal equivalent for 10th and 100th. See, 0.1. How to place as a fraction? You will remove the decimal. Now what you will check? After decimal, how many digits you have? You have only one digit. That means as a denominator, that many zeros as multiple of 10 you have to keep. 1 upon 10. It's same when you convert this fraction as a decimal number, 0.1. The same 0.03. How will you place as a fraction? First you write 3 as a denominator. Now after decimal, count the number of places. How many digits you have? 2. So that many zeros you have to keep as a denominator, like 100. Clear? 0.5, 5 upon 10. 0.08, same way, 8 upon 100. Why I kept here 100? Because after decimal we have 0 and 8, two number. Why? 0 is on 10th place and 8 is on 100th place. That's why in short you can say 8 upon 100. So here also two more examples we have. 0.44. See, I have not read it yet. 0.44. No, this is not the way to read the numbers. How will you read? 0.44. 0.58. Okay, this is the right way to read the decimal numbers. How will you represent as a fraction? 44 upon 100, because out of 100 the 44th part is this. The same way 58 upon 100. Clear? Now next, like and unlike decimals. What is like decimal? The decimals having same number of decimal places are called like decimals. For an example, can you see 3 numbers back to back? 0.05, 1.23, 18.19. See, here I have not read this number 18.19. No, I can't. How will I read? 18.19. Now what was the question? Like or unlike? This is like. Why? Because see, after decimal, how many decimal places we have? 2. Why? Because 0 is on 1 and 5 is on 2. Second, So that means after decimal, how many digits we have, that many number of decimal places we will count. So 0 and 5, 2. 2 and 3, 2. 1 and 9, 2. So same way here, in each and every digit, in each and every number, we have number of decimals places 2. So that's why they are like decimals. Clear? Now, unlike decimals, decimals having different number of decimal places. See, in like decimal, all the decimal places are same. After decimal, how many number of digits? We have 2. Can you see this example? Yeah. Now, unlike decimals having different number of decimal places are called unlike. Why? See here, 98.2. After point, we have 1 digit. Here, after decimal, we have 2 digits. Here, after point or decimal, we have 3. So in all the 3 examples, different places of number we have. That's why they are unlike decimals. Clear? Very easy concept. Now one more example, like and unlike. So same number of digits after decimal point. You can see here, after decimal point, we have 2 number of digits, 7 and 5 and 1 and 5. So they are 2 in counting, they are 2 in numbers. That's why they are like decimals. And here unlike, why is it so? Because 3.67 and 4.5 after decimal, here I have 2 number of digits and here I have only 1. So in this way they are unlike decimal. Now the question is how to convert unlike decimals into like decimals. Now convert unlike to like decimal. Unlike decimals can be converted into like by adding required number of zeros, okay, in decimal place, and this doesn't affect any change in the value of decimal. How? I'll show you. Example, decimal 7.1 and 18.34 are unlike. Why? Because see here, decimal places we have 1, after decimal we have only 1 number of digit, and here 2. So here 1 decimal place, here 2 decimal place. So what you will do? Now 7.1 can be converted into decimal having 2 decimal places by adding 1 more 0. How will you add it? See, I'll show you. 7.1 and 18.34. Here already we have 2 decimal places, but here I have only 1. So here 1 more 0 I will add it. Clear? So 7.1 can be converted into a decimal having 2 decimal places by adding 0 as its 100th place. So it will come here. So 7.10 and 18.34. This way it will count, it will convert as like decimal. One more, 3.429. Now 65.3. Now this you have to convert as a like decimal number. To make them like decimal, we write zeros behind the decimal part of the decimal number which has less number of digits. Here how many number of digits we have after decimal? We have 3. Here I have only 1. So I will make this 3 number of digits. So how many zeros are less? 2. So that many zeros I will put behind it. So it will become 65.300. Now you can compare. These are like. Why? Because after decimal we have 3 number of digit and here also 3 number of digit. So this way they are like decimal. Clear? Thank you. Next we will discuss in live session.